Welcome to video lecture 6B. This is when we're going to be talking about measures of variation. The first example is about two different banks and the wait time in line at Best Bank versus Big Bank. The first thing we want to talk about is the mean and the median. Now, for this first one, I've mixed up the numbers because in most real-life situations, these won't be nice and in order from low to high. So what I'm going to do is I'm going to separate them each by a comma, then copy and paste it into Microsoft Excel. But notice it keeps it all in one cell. So what I'm going to go to is text to columns under my data. And here I'm going to say deeliminate, and I have commas separated. Next, finish. There we go. Now if I want these instead of in a column, I'm going to copy, paste special, and transpose. So now that all of my data is in a column. Now we can sort this. Let's say this is Best Bank. I think it was Best Bank. Yep, Best Bank. And I want this sorted from small to large. There we go. So now my numbers are now from small to large, and I can see that my 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. My median is 7.2, like is stated in our example, and the mean for both of these is 7.2, which we can also calculate in Microsoft Excel by doing equals average, tab, highlight my cells, and it will, there we go, my average is 7.2, just to verify. And again, calculated from Best Bank, this one is in order from low to high, which I need to do to find my median, which is 7.2. And again, if I were to calculate these, I would also have a mean of 7.2 for the average. Below we have a frequency chart that I have created into a histogram, and we have Big Bank here and Best Bank here. Our first question is, which bank will have the most complaints? Just looking at the data, don't look at my answer, just looking at the data, any ideas about which bank is going to end up having the most complaints? Over here, from about 6 to 6.9 and 7 to 7.9 is the wait time. Here from 4 to 4.9, 5 to 5.9, clear up to 11 to 11.9. We have one wait time of 11 minutes. My idea is that I'm going to have more complaints at Big Bank. But why? Because some people have wait times clear down to 4 and 5 minutes, where Best Bank goes from 6 to 7.8. More customers will be unhappy at Big Bank because those who have to wait long will become frustrated when they see others that are only waiting a few minutes. And my other thought is that people at Best Bank know that everyone's being treated fairly, and they also know what to expect. So if everyone's taking approximately 7.2 minutes, then they're going to anticipate their wait time to be about 7.2 minutes. And I'm going to go ahead and highlight these two different colors because I have two different thoughts for my answer. All right, let's move to Roman numeral 2, or range. To find the range, we find the difference between the highest and the lowest values. Math is a separate language, and we translate from English, or from any language for that matter, into mathematical operations. So when I say difference in English, in math it really means we're subtracting. So to find the range, or the difference between the high and the low for Best Bank, we're going to take the high minus the low, which is up here. The high was 7.8, and if you didn't have that right off the bat, you could look at our list. The high is 7.8, the low is 6.6. Subtracting those gives us 1.2 minutes. And so my range is 1.2 minutes. The range for Big Bank, right here, the high is 11 and the low is 4.1 because this was in from order from low to high. 11 minus 4.1 gives us 6.9 minutes. The larger the range, in this case, especially for Big Bank, it's reflecting that it has a larger variation, meaning I have a lot more variety at Big Bank versus Best Bank. There are different situations in which the range can be misleading. For instance, if I have the scores for quiz number 1 as 1, 10, 10, 10, 10, 10, 10, 10, 10, and I find the range for quiz number 1, the high is 10 minus the low is 1, gives us a range of 9. Versus the scores for quiz number 2, 2, 3, 4, 5, 6, 7, 8, 9, 10. To find the range here is 10 minus 2, giving us a range of 8. In this case, having the larger range of 9 was misleading because a larger range usually says larger variation. And in this one, quiz number 1, I really only have 2 scores, 10s and a 1, 10 and 1. Versus quiz number 2 with the smaller range, it has a much larger variation. In fact, so great that none of them are duplicates. So the larger range from quiz number 1 would be indicative of having a larger variation. However, our outlier here, this 1, creates it a larger range. If we were to exclude it, there would be no variation at all. Versus quiz 2, we have a smaller range, but it has a much larger variation. Number 3, Roman numeral 3, quartiles and the 5-number summary, also known as the Fantastic Five. Quartiles divide your data into 4 sections, so it's doing exactly what the name sounds like. And you must make sure that your data is arranged from low to high. Now, in most of our examples and problems, they will be arranged from low to high. If you do get a list of numbers that aren't from low to high, you can go ahead and type them in like we did here, and then using your data text to columns, and then copy and then paste special and transpose, it'll take it from low to high, and then home sort from low to high, smallest to largest. So you could do that as well if your data is not from low to high. All right. Because the quartiles are dividing the data into 4 equal sections, down here in this quartile, we have a fourth of the data. Between the lower quartile and the median is another fourth of the data. And from the median to the upper quartile is a fourth of the data. And from the upper quartile to the highest, or to the upper, is another fourth of the data. And don't forget, from low to high. All right. The Fantastic Five from Big Bank, we need our lower quartile, so we're just going to divide it in half and divide it in half and divide it in half. So the easy ones are finding the low and the high, which we already found when we found the range, and low and high, which we found here, 7.8 to 6.6 and 11 to 4.1. But then we're going to take our data here and find the median, which we did with 7.2. And then to find the lower quartile, we divide our data over here in half again. So for Big Bank, the lower quartile is 5.6, as it happens to be in the middle of the low and the high, or of the median. So 1, 2, 3, 1, 2, 3, 5.6. And again, for the upper quartile, 1, 2, 3, 1, 2, 3, there we go, 8.5. And that will be our upper quartile for big bank. Using the same method, for best bank, we'll get 6.6, 6.7, 7.2, 7.7, and 7.8. Now, if you have an even number of data where it doesn't work out nicely, again, just like we did previously to find the median, if the lower quartile encompasses two numbers, just find the mean. The Fantastic Five come in handy for when we make something known as box and whisker plot. We can do this by hand, which is much easier than Excel, but if you would like to do this in Excel, here's a link. YouTube, watch V equals ZFBPNW KWVWK for a fantastic tutorial in which you can use to create a box and whisker plot in Excel. I won't be going through that in this video lecture. If you do go through this tutorial, their quartiles that Excel finds are slightly different from the way the book finds them, and that will make your homework in my math lab off slightly. So I would do these by hand or by calculator, and then follow the rest of the tutorial if you would like to create your box and whisker plots. All right, and right here it shows that the median is at the exact same spot, 7.2, and best bank starts clear down here and goes clear up here. And remember, these had the same amount of data points, so this has a much larger variation, for the data is spread all the way across, and best bank has the same amount of data, so all of these data points are squished much closer together, showing that the variation is much smaller. All right, here's our next one. Race times, example B. Here is race times for set 1, and these happen to be listed from smallest to largest, and set 2 is also being listed from smallest to largest. And we're going to find the Fantastic Five. These ones have an even number though, and so we're going to have to average to find the lower quartile, the median, and the upper quartile. And because these are pretty much lined up on top of each other, we can assume that this to here will be the two middle numbers. And we can count just to make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's not a number in between 10.13 and 10.14, so we have to find the average of those two, which will give me the median for set number 1 as 10.135. Now that I know that this is the median, to find the lower quartile, I need to cut the lower section in half, and I'm going to find that by counting again. 1, 2, 3, 4, 5. 1, 2, where did I go? 1, 2, 3, 1, 2, 3, 4, 5. There we go. So it's between those two. Because remember, our median is in between those two numbers. So 1, 2, 3, 4, 5. Starting at the bottom, 1, 2, 3, 4, 5. All right, using your calculator to find the average between these two numbers, we will get 10.065 for the lower quartile. And for the lowest number, or the low, we take the smallest, 9.92. And now we're going to go ahead and find the upper quartile. Now remember, the median happened between these two numbers, so we're going to count in 1, 2, 3, 4, 5. Starting at the low, 1, 2, 3, 4, 5. So again, we're going to have to average these to find the upper quartile. Using your calculator or Excel, we'll get 10.195. And then for the upper, 10.38. So that was pretty easy to find. Again, we'll go through the same process here, and because it has the same amount of data points, we can follow the same pattern of averaging these two to get 11.015. The low is 9.89, or this has been rounded to 9.9. I'm going to put it 8 in there. And the lower quartile, we're going to count in 5, 1, 2, 3, 4, 5. And from this side, 1, 2, 3, 4, 5. There we go. And the average for those is 10.38. And their companions down here, 1, 2, 3, 4, 5, will be averaged into 11.655 and the upper of 12. So that's how we find the fantastic 5. Those give us our 5 number summary. And using these, we can create our box and whisker plot. By hand is easier, but again, you can go back to this tutorial. I'll show you once again, in which you can create your own box and whisker on Excel. Right here, because these have the same number of data points, and this one is much more spread out compared to this one, we can say that this one has a much greater variation and this one a much smaller variation. Roman numeral 4, standard deviation. This means kind of like the average kind of deviation from the mean. The data points, it measures how far the data point values are spread around the mean of the data set. So kind of here's the mean, or kind of the mean, because the median and the mean are pretty close, and it kind of shows how it's spread around. Here's our formula. Standard deviation equals the square root of the sum of deviations from the mean squared deviation from the mean, meaning that it's subtracting the data point from the mean value, and then it's squaring it and dividing it by the total number of data values, subtract 1. So we're going to show you how to do it by hand quickly and then use Microsoft Excel. So here we have our data points from best bank, from smallest to largest, and big bank from smallest to largest. What we want to do first is find the data point, subtract the mean, or its deviation, and of course some of them will be negative, and then we square that to get rid of the negative so that when we add them, they won't start subtracting away from each other. Then I add my deviations squared, and then I divide by the total number of data values, subtract 1. So let's count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to do 11 minus 1, so I'll divide this by 10 and then square root the whole answer. And I've shown you here, but I'm going to go through how to do this in Microsoft Excel. And I'm going to use the information we already copied in there. Here we go. Now I have the mean, so I'm going to highlight that so I don't actually accidentally use it as a data point. Now I want to find the deviation. And that means I want the data point equals, because I want it to calculate, the data point subtract the mean, and I want it to always subtract this mean, so I'm going to press F4 so that the mean is an absolute cell reference, and press enter, then click back here and then move my cursor over here until I get my plus sign or cross sign, whatever you want to call it, left, just one click and then pull it down. There we go. That's how far all of these data points are from the mean. The next step is to find the deviation squared. So I'm going to calculate each of these to the left and shift caret or 6 squared, press enter, And now I'm squaring all of these to copy that equation. And I don't want any absolute cell references here because I want it to move as I pull down with each of these down. There we go. Now I've taken each of these deviations, and just to double check, I can double click in there and press enter to get out of the cell equation. Now the next part was the sum of those squared deviations from the mean. So I want to find the sum, and I'm going to type that in here so that I know I found the sum in this one. Equals sum, click, hold the click and pull, let go, and then press enter. There we go. There's my sum of all of my data points. So I have completed this first part of the equation. Now I need to divide that by the total number of data values, subtract 1. So this is going to be divided by 10. Oops. Here, divide by, oops, I need to press my numlock. Divide by 10, and equals this value divided by 10. There we go. And so now I've done this inside portion. Now I need to square root what I got from that. So now I'm going to put square root, and to calculate the square root, we'll press equals SQ, and it brings it up as SQRT, so I can press tab, or I can finish typing it in with an open parenthesis. I want to square root this number. I can close parenthesis or just press enter, and there we have our standard deviation right here of 0.444972. If I wanted to, I can copy and paste it into here if I needed it in an Excel or a Microsoft Word document. So there's my standard deviation, and you can do that on your homework supplement as well. And you can copy all that and put in your work. Or you can say equals standard deviation, STDEV, in Microsoft Excel. I guess we should bring it down here. Let's say STDEV, and we'll put it here to calculate standard deviation. Press tab. Here are all of the numbers, and it will calculate it for you. So you have two different ways to go about finding the standard deviation. And again, we did it over here for best as well. There we go. So now we have our two standard deviations for best bank and big bank. Let's interpret what we just found as standard deviation. The range rule of thumb for standard deviation is you take the range and divide it by 4. Also, if you know the standard deviation, you can find the approximate range by working your backwards, because it's the range divided by 4. 2 of the standard deviations will be above and 2 below, which will give you the low and the high. So it's approximately, the low is approximately equal to the mean minus 2 standard deviations, and the high is approximately equal to 2 standard deviations above. All right, so let's work backwards, because now I know the range. We calculated that in Roman numeral 2, 6.9 and 1.2. We can use our range rule of thumb and approximately find the standard deviation. 6.9 divided by 4, we can use Microsoft Excel to do that, equals 6.9 over 4, which gives us 1.72, or 1.7, and again 1.2 divided by 4, 12 divided by 4 is 3, move your decimal over is 0.3, and let's compare it to our actual standard deviations, 1.9 and 0.4. The range rule of thumb is pretty close. It's not perfect because it's rule of thumb, but it kind of gives you an idea of how to do it without having all of the data points. We can also work backwards. So if I have a BMW and I'm going to estimate the range where I have the mean is 22 miles per gallon and I know the standard deviation is 3 miles per gallon, I can use that information to approximate the minimum number or the low and the high. So I'm going to use my range rule of thumb here by taking the mean, which I have, of 22 and subtract 2 standard deviations and add 2 standard deviations. So I have 22 and I'm going to add and subtract 2 times 3 for the minimum and the maximum. 22 minus 2 times 3 is 6, which gives us 16. And then I have 22 plus 6 gives me 28. Using my range rule of thumb, I have an approximate range of 16 to 28. I hope you join me for the next tutorial for 6C.